Now we're going to expand on the idea of transformations on these trig functions. So we're specifically going to look at amplitude, frequency, and period. Those are three very important concepts when dealing with trig functions. And when we look at the domain and range of y equals a sine of x or a cosine of x, so when you substitute different values in there for a, let's see what happens. In the calculator, I'm going to graph y equals sine of x and y equals 3 sine of x. The window, I just changed the x values to be from 0 to 2 pi, so that's in general one full cycle of the sine curve, and then the y values from -3 to +3. So if I graph that, the first one will be the sine of x, and then the thicker one that comes in will be the 3 sine of x. So what happens here is notice that the local extrema, local maximum, instead of being at 1, is now up three times higher at +3. So if I press trace on sine of x, and I put pi over 2, I'm at 1. If I go up to the other curve, and put in pi over 2. So now you can see I'm on y2 equals 3 sine of x. Pi over 2, press enter. Now I'm up at 3. So all that the a value does in front of the sine or cosine graph is it multiplies your y values by 3. So any 0 will still be the same value. So it doesn't change horizontally what is happening. It just changes vertically. So it's a vertical stretch basically. So your local maximum, instead of being at a y value of 1, now it's 3 times higher. And the minimum, instead of being at -1, is now 3 times lower at -3. And you can graph the cosine of x and 3 cosine of x to see the same idea. So as far as domain and range go, the domain of a sine of x and a cosine of x is -infinity to infinity, basically saying your angle can be whatever angle you want it to be. And then the range depends on your a value, so the number in front of sine or the cosine function. So it'll go down to -a and up to +a. So 3 sine of x went down to -3 and up to +3. So that number in front of a, that number in front, a, is called the amplitude. And the amplitude is the absolute value of a, and it represents half the height of the wave. It's the distance from the horizontal center to the max or the min. So on our graph of y equals 3 sine of x, the distance from the lowest to the horizontal center, that distance is 3. The total height of the wave from -3 to +3 is 6, but half the height would be 3. So you have to be careful with that you go from the horizontal center to the lowest or the highest point, and that distance is the amplitude. So the amplitude for each graph and then the range, take a minute and try those, and you can graph them to help you with your answer or just to see what's going on. And I'll show you the answers. Okay, so the amplitude in the first one is 3. Remember that it's the absolute value. So in part B and C, we have negative in front. So the amplitude is +5 and +1 for part C. And then I give you the range. Okay, so the next thing, using our calculator, we're going to graph each of the following from 0 to 2 pi. So we're going to graph sine of x, sine of 1/2 x, and sine of 2x. And this is, again, is just kind of building off the transformations of trig functions. And we'll see what happens when we graph sine of x and then sine of 1/2 x, and then we'll look at sine of x and sine of 2x. So we'll do those separately. Here I have y equals sine of x and y equals sine 1/2 x. If you wanted to, you could enter 0.5x for the angle in part 2. I just put 1/2 because if that was sine of 2/3 x, you don't want to round it to 0.67 or 0.66. You don't want to do that. You want to put the fraction in. But with a terminating fraction, it's okay to put the decimal. So just be careful with that. I also changed the window just back to the y min and max to be -2 and +2, just so it shows up nicer. So then I'll graph them. So there's the sine of x again, and then here comes the sine of 1/2 x. Okay, so notice what happens there is that top part of the curve, it got stretched horizontally. So we only get the top half of the sine curve. So if we look at it in terms of how many sine curves we have, for sine of x, we have one full cycle of the sine curve. For sine of 1/2 x, we only have half of the curve. Now we're going to go and graph y equals sine of 2x. So we have sine of 2x and y2, so when we graph that, again, here's the sine of x. So there's one full sine curve in 2 pi radians. And then here comes sine of 2x. Now notice we have one full curve that ends at pi, or 180 degrees. And then the second curve ends at 2 pi, or 360 degrees. So sine of 2x has two full sine curves, or sine cycles, that occur from 0 to 360 degrees, or 0 to 2 pi radians. So if we think about what's happening is with sine of 1/2 x, we have half of a sine curve from 0 to 2 pi. So here's the sine of x. And then with sine of 2x, we have two full curves. That's the one that's on the screen over there. So think about the effect of b on the graph of y equals sine of bx. And we could also graph the cosine of bx, and we'll see the same thing happen. So what b does, it tells us how many cycles of the curve occur in 360 degrees. And remember, for the sine curve, this is one full cycle of the sine curve. The cosine curve, remember, that starts up at 1 and then comes down and then back up to 1. So that's one full cycle of cosine. So the b value tells us the frequency, or how many cycles of the curve occur in 360 degrees. Okay, so that brings us to the definition of frequency. That's the absolute value of b. And that tells us how many waves there are in an interval length of 2 pi radians, or 360 degrees. So again, with sine of 2x, there were two full sine waves in that interval. Now the period, what that tells us, 2 pi divided by the absolute value of b, or 2 pi divided by the frequency, that tells us, the period, tells us how long it takes to complete one full cycle. So if we only wanted to see one cycle of the sine curve, we would have to go from 0 to 360 degrees, or 2 pi radians. If we only wanted to see one full cycle of sine of 2x, we would have to go just half the distance from 0 to 2 pi. So I'll show you what I mean by that. If I go change my window, so I'm going to graph sine of 2x. And remember, right now, from 0 to 2 pi, there's two full cycles. To see one cycle, I want to end here. So if I change my window to the x maximum just being pi radians, now when I graph it, there's going to be one full cycle. So the period of sine of 2x is pi. So if I take 2 pi divided by absolute value of 2, that gives me pi. If I looked at sine of 0.5x, I change my window from 0 to 2 pi again. And now I'm graphing sine of y equals sine of 0.5x. Remember, we only had half the curve. So the frequency is 1/2. The period, how long does it take one full cycle to occur? We have to go twice as far. So my window has to go to 4 pi. So if I enter the x max to be 4 pi, now when I graph it, I should see a full cycle of the sine curve. Okay, so the period there, 2 pi divided by 1/2 will be 4 pi. So that's how the frequency and period are related together. So you need to remember those two terms. Frequency, how many, if you go an interval of 2 pi radians or 360 degrees. And I want to point out that you don't have to go from 0 to 360 degrees. You could go from 90 degrees to 450. So any interval of 360 degrees. So whatever angle you start at, if you go 360 from that, then that's your interval length of 360. So on the second side, but if you pause the video, and here's the answers to these, finding the amplitude, period, and frequency. So amplitude is the absolute value of the number in front of the sine or cosine function. The frequency is the b value. So in part A, the frequency is 4, which means if you go from 0 to 2 pi radians, you're going to see 4 complete sine waves in that interval. And then the period, 2 pi over b, so 2 pi over 4, which is pi over 2. So that tells you that there's one full sine cycle in pi over 2 radians. Okay, and then the others are similar to that. The trickiest one will be the part D, with a sine of bx plus c. The amplitude is a. The frequency is b. And then the period is 2 pi over b. So that's just kind of a generic representation. With the range, the horizontal center is going to be at the c value. So that plus c is a vertical shift c units. So to get to the maximum, you would take that c value and add a. To get to the minimum, you take the c value and subtract a, the amplitude. So there's your range from c minus a to c plus a. So that one's a little bit trickier. And then in number 5 is just graphing the two functions I have, so you can look at those. And when you sketch a graph of trig functions, you should always label something on your x-axis or your theta axis, representing your angle. I'm just showing going from 0 to 2 pi, so I put the pi and 2 pi in there. And then I just label the middle, the horizontal center, and then the maximum and minimum y values. You don't have to go too crazy with plotting points and all that. Just do the best you can to sketch it. Okay, so that's amplitude, period, and frequency. And you'll have to really know those when you deal with trig functions.